x. So function notation looks a bit like this, and this is pronounced f of x. And what it means is that, first of all, the main thing, f of x, essentially just means y. And you might ask yourself, well, why do we need another name for y? Isn't y perfectly good? Well, the problem is this, is when we look at functions like y equals 2x plus 3, and maybe y equals negative 7x minus 5. We'd like to be able to refer to these functions by different names. So one way to do that is instead of saying this guy's y and this guy's y, we just make this guy into, well, I'm going to call it g of x, and we'll make the first guy into f of x. And then when we do, we've got unique names for our functions. We can refer to f of x and g of x. Another really cool thing about function notation is that when you use it, if you say f of x equals 2x plus 3, when we do figure out what y is, we'll know what x was at the time. So for example, if I say f of negative 5 equals 2 times negative 5 plus 3, well, what we learn is that y is equal to negative 10 plus 3, which is negative 7. But now because we plugged in the negative 5 in place of x, and we see it here, we can say, oh, y is negative 7 when x is negative 5. So this is actually the same as saying negative 5 comma negative 7. It's kind of a similar thing. So function notation does two things. It lets us identify which function we're talking about, and it also lets us remember what the x value was when we get a particular y value.